طلابنا الاعزاء بنرحب بيكم في حلقه جديده من برنامجكم تبسيط العلوم. وصلنا معاكم النهارده لجزء مهم جدا وشرح مهم جدا في ماده الماثماتكس بشكل عام والفرع الخاص بالسوليد جيومتري. احنا معاكم النهارده ومع نهايه وختام شابتر 4. يا رب ان شاء الله تكون المتابعه جميله وتستفيدوا منها، ومع كل الاسئله والامثله اللي احنا هنقدمها ليكم النهارده مع مستر عبد الناصر الجابر خبير ماده الماثماتكس بوزاره التربيه والتعليم. مرحبا بك.
مرحبا.
مرحب بحضرتك، وبنقول الحمد لله قربنا او اوشكنا على
خلص.
ختام السوليد جيومتري، صح كده؟ تمام. اخر جزء النهارده هيكون عن
عندنا البيراميد والكون، وازاي نجيب اللاترال اريا والتوتال اريا والفوليوم.
جميل.
ده اللي هنشتغل فيه ان شاء الله من دلوقتي
ان شاء الله. يعني دي تعتبر فعلا اخر كده دروس بسيطه جدا في الشابتر 4 يعني.
تمام.
جميل. سهله ولا صعبه بقى؟
لا سهله جدا
ان شاء الله. فيها ارتباط مع الجزء اللي فات، يعني كل الشابترز يا مستر بتؤدي
طبعا كل الحلقه اللي فاتت انهينا بنتكلم بقى على البيراميد بتكون ازاي. هنبدا نتكلم منه ان شاء الله.
جميل.
نبدا بيه تاني.
طيب نشرح بقى البيراميدز مع حضرتك النهارده والامثله الخاصه بيه. اتفضل يا فندم.
يلا بينا. try to go to the slide. We have speak about pyramid. The pyramid have a base. In fact, pyramid have many bases. Maybe triangle, maybe quad, maybe pentagon. So it's as a base. We call it pentagonal, triangular, or square pyramid. So we have here square here, and we have 4 triangles. If you fold it, will be get a pyramid MABC. And look carefully for this. We have MN. MN here is the height, and MX is a slant height. Slant height, that's a height perpendicular to the base CB, and bisect the base in the point X. So CX equal XB, and XN equals half the length of BA. So let's go to the next one. We have the same pyramid here, but we have different base. A, B, C, D, H will be pentagon. So it is pentagonal pyramid. And we have MN here, the height, and MX is a slant height.
طيب مستر عبد الناصر، يعني طبعا زي ما حضرتك قلت النهارده ان اجزاء جديده واحنا بنشرح شرح يعني او بنوضح بعض المفاهيم الجديده. عايزه بس اعرف من حضرتك يعني بالنسبه للطالب الشكل العام للمراجعه بقى ازاي، يعني هل بياخد كل شابتر على حده ويبدا ان هو يحل عليه، ولا بما ان ماده الماثماتكس او تحديدا السوليد جيومتري مرتبطه مع بعضها البعض فلازم هو يراجع كل الشابترز بعدين في النهايه يبدا يحل بشكل عام؟
والحقيقه انا افضل ان هو يعني على حسب الطالب بقى هو ذاكر ازاي في قبل كده يعني. لو هو مذاكر درس بالراحه ممكن يبتدي يحل امتحانات بقى او يشوف الاسئله النهائيه على كل شابتر. ولكن لو ما ذاكرش قوي يبقى يبص على الحالة بتاعتنا ويراجع ومن خلالها يفتكر المعلومات ويبتدي بقى يحل الأسئلة.
أكيد. ولكن طبعا السوليد جيومتري تعتبر يعني من الفروع الممتعة جدا طبعا في مادة الماثماتكس، وعلشان كده النهارده هنستمتع معاك بهذا اللقاء ونكمل الجزئية اللي حضرتك بتقدمها.
أهلا وسهلا. طبعا. We have the pyramid. It's a solid of a single base and all of its other faces are triangles like that have the same vertex. The pyramid is called triangular, quadrilateral, pentagonal, as we said, pyramid, according to the number of sides of the base. We have here pentagonal pyramid. Note, in the opposite figure, MABCDH is a pentapyramid with vertex M, and its base is the polygon ABCDH. Its lateral faces are the surfaces of triangles MAB, MBC, MCD, and MDH, and also MHA. And its lateral edges are MA, MB, MC, MD, and MH. Okay? The same pyramid here, which is pentagonal pyramid, because it has 5 sides here, A, B, B, C, C, D, D, H, and H, A, and we have the height, MN, and slant height, MX. The height of the pyramid Mn is the distance between the pyramid's vertex and its base level. The slant height is the distance between the pyramid's vertex and any of its base edges. We have the pyramid here, which is pentagonal. We have a regular pyramid. What is a regular pyramid? It's a pyramid whose base is a regular polygon. Its center is the foot of the perpendicular from the vertex to its base. We have here A, B, C, D, H is a regular pentagon, which means all sides are equal in length or angles are equal in measure. So, properties of regular pyramid here: its lateral edges are equal in length, its lateral faces are surfaces of isosceles congruent triangles, slant heights are equal. We have here different pyramid. Why it is different? Because the base here A, B, C, D is a square, and we have the same height Mn, a slant height Mx, and Nx here is half of the side BC. It's quadrilateral or square pyramid because its base equal is a square or a quad. Note the perpendicular straight line drawn from the top of the pyramid to the level of its base is perpendicular to any straight line in it. That means if Mn perpendicular to the plane ABCD, then it will be perpendicular to any line on this plane as Nx, Nb, Nc, Nd, and Na. So we can say that Mn perpendicular to each side in the quad ABCD. So in the opposite figure, if Mn is perpendicular to the base level, so Mn is perpendicular to AC, Mn perpendicular to BD, and Mn also perpendicular to Nx. The triangle MXN is a right angle triangle at N. Look carefully at the triangle MNX because it's right angle triangle at N, and we will use Pythagoras theorem to find any side will be unknown. Example, MABCD is a regular quadrilateral pyramid. The length of its base side ABCD equals 10 and its height equals 12 centimeter. Find its slant height. Solution: look at this pyramid. We have here MABCD pyramid and regular. Regular means that DABC, this base is square and each side of course are equal length, and we have XN here equal half the base BC. We have the side length equals what? Equals 10. So XN will be 5 centimeter, and we have the height is Mn and slant height Mx. Solution: the pyramid is regular quadrilateral, so Mn perpendicular to the plane ABCD, wherein is point of intersection of the diagonals of the square ABCD, so Mn equals 12 centimeter. Let X the midpoint of BC. Mx will be perpendicular to BC. Why it is perpendicular? Because the triangle MBC is an isosceles triangle, and from the previous studying that if we have an isosceles triangle and we have a median inside it, so the median will be perpendicular to the base, and Mx is a slant height of the regular pyramid. Like that, we have here Mn is the height, which is equal 12 centimeter. Nx have the base side, which is 5 centimeter, and you would like to find Mx. We will find it from Pythagoras theorem, of course. In triangle DBC, N is the midpoint of DB, so X is the midpoint of BC. We have here Nx equal half DC, equal half times 10 equal 5 centimeter. Mn is perpendicular to the plane ABCD, So the triangle MNX is a right angle triangle at N. And from Pythagoras theorem, we have here xm power 2 equals mn power 2 plus nx power 2. And we calculate them, we'll get 169. And by taking the square root of this number, because we have here mx power 2, we would like to find mx only. So we have to find the square root of mx power 2. The slant height of the pyramid will be 13 centimeter, and the opposite figure shows one of the net of the pyramid MABCD, like that. We have here the square base, its side equal length, and we have 4 triangles as faces here. Slant height equals 13 centimeter. Right pyramid. What is right pyramid? The pyramid is right if and only if the projection of the perpendicular drawn from the vertex of the pyramid to the base passes through its geometrical center, like that. This pyramid MABCD is a right pyramid. Why? Because here MN is perpendicular to the base, which is ABCD. And geometric center here, it's the center of square ABCD, which is the point of intersection of the diagonals. We have diagonals here AC and DB. N is the intersection point of them. Think, is the regular pyramid a right pyramid? Explain your answer. Regular pyramid, of course, will be a right pyramid because it is already will be the height will be perpendicular to the base. Are the slant height of the right pyramid equal in length? The height of the right pyramid, in fact, they doesn't have equal in length, but if the pyramid will be equal in length. Note, the pyramid is said to be triangle regular pyramid if all of its faces are equal, equilateral triangles, so each face can represent a base of the pyramid.
مستر عبد الناصر معاك ومع أعزائنا الطلاب هنروح لهذا الفاصل، نعود بعده لاستكمال باقي شرح برنامجنا وحلقتنا في تبسيط العلوم. ابقوا معنا. عودة مرة أخرى أعزائنا الطلاب لمتابعة هذا اللقاء. بنجدد لكم التحية من جديد، وعودة مرة تانية مع مستر عبد الناصر وفرع مهم جدا في الماثماتكس. معانا السوليد جيومتري، معانا النهاردة آخر شابتر فيه هو شابتر 4 وشرح مبسط لبعض المصطلحات الموجودة فيه، وطبعا التطبيق العملي عليها من خلال بعض النماذج والأسئلة. نرجع لحضرتك.
تمام يلا بينا بقى نروح للتوتال اريا اوف ريجولار بيراميد. The regular pyramid here contains square as a base and 4 sides and 4 side bases, 4 triangles. Each triangle here, its area equal half times base times height, and the area of triangle or area of square will be side times side. So we have a slide here for triangle and the base. Note the lateral faces are congruent, so triangles whose slants are with congruent heights, equal lengths of course, and each of them equal L. The base of the pyramid is a regular polygon whose side lengths equal X. Then the lateral area of the pyramid here equal the sum of the areas of the lateral faces. We have here lateral faces. We have 4 lateral faces in fact, and each face is a triangle, and each triangle has a base and a height. So this first one equal half X times L, the second half X times L, the third half X times L, and the fourth half X times L. So if we add them, we have half as a common factor, and x plus x plus x plus x times L. So half the perimeter of the base of the pyramid multiplied by the slant height. So the area, the total area of the pyramid equal lateral area and the area of the base. Concentrate carefully. We have here the lateral area of any pyramid equals half perimeter, not area, half perimeter of the base multiplied by the height or the slant height. So if we have an example here to find the lateral area, using the opposite net, describe the solid and find its total area. We have here a base, squared base equals 10 centimeter as length, and we have edge equals 13 centimeter, and we would like to find out its total area. This net will confirm or will make a solid geometry, which is a pyramid. So the net for a regular quadrilateral pyramid, its base is square, whose side length equal 10. The length of its lateral edge equals 13 centimeter. The lateral face MAB is an isosceles triangle, as we see here. MH is a slant height. H is the midpoint of AB, which means that AH equal 5 centimeter. In triangle MHA, which is right angled at H, we find that this is a pyramid here. The base is square, the edge is 13. MH power 2 equal AM power 2 minus AH power 2 from Pythagoras theorem. MH power 2 equals 13 power 2 minus 5 power 2 equals 144. And taking square root of the two sides, so MH will be 12 centimeter. So the lateral area of the regular pyramid here equal half the perimeter of base multiplied by slant height, and equals half multiplied by 10 times 4. 10 times 4 is the perimeter of the base, because the base is square. The base is square, so its perimeter equals side times height, side times 4. So half times 10 times 4 times slant height, which is equal 12, 240 square centimeter. The area of the pyramid base as a square, it's S power 2, or side times side, it's 10 power 2, so it's 100 centimeter square. The total area of the pyramid equal 240 plus 100 equals 340 centimeter squared. Let's go quickly to the next slide, volume of pyramid. If we have a pyramid here, the volume of the pyramid equals 1/3 of the product of area of the base multiplied by the height. The height, not slant height, which means the volume of pyramid equal 1/3 base area multiplied by height. This is height. Look carefully. Height, don't write it as slant height, where B is the area of the base and H is the height of the pyramid. Example, calculate the volume of the regular quadriangular pyramid. The length of its base side is 18 centimeter and its slant height is 15 centimeter. Look carefully at this drawing. We have here a pyramid, and we have a slant height equals 15 centimeter, and the base equals 18, and we have height here. We have to find the height. First, calculation of the area of the pyramid's base. The pyramid is regular quadriangular. Its base is square shape. The area of the pyramid equal base equals 18 times 18 equals 324. It is the area of the square of the base. Here we will complete. Second, calculation of the pyramid of height h. We have here the height, it's unknown, and we have this h equal 15 and half the base equal 9. So we will apply the Pythagoras theorem. H power 2 plus 9 power 2 here equal 15. So h power 2 equal 15 power 2 minus 9 power 2. It's equal 144 centimeter. And by taking square root, h equal 12 centimeters. So we have the height equal 12 centimeter. Since pyramid's volume equal 1/3 area of base multiplied by its height, which is 12 centimeter, so the pyramid's volume equal 1/3 multiplied by the area of the base, which is 324, multiplied by 12, which is the height, equals 1,296 cubed centimeter. Look carefully, it's cubed, not squared, because it's a volume. Remember a very important rule here. Surface area of a regular polygon of n sides, as pentagon, hexagon, octagon, and so on, of length of each of x side is equal x, equals n over 4. N means the number of sides. X is the length of its side, x power 2. Cotan pi over n. Pi means 180 degrees over n, which is the number of sides. A right circular cone. Let's go to the cone. It's a solid which is generated from the rotation of a right angle triangle, a complete revolution around one of its sides of the right angle as an axis. Look carefully at this. We have here a triangle ABC. If we revolve or make a complete revolution about AB, AC will be the drawer here, and it will make a cone. We have cone vertex A, cone drawer, which is AC, cone axis, which is AB, and the base, which is the circle. Radius of the circle equals CB, and the base is the circle, of course. The opposite figure shows a right circular cone constructed from rotation of right angled triangle at B, a complete rotation around AB as an axis. We will find that. Properties of a right circular cone. We have here the cone again. First, AC is a cone drawer. A is the vertex of the cone. The point C draw during a rotation a circle. Its center is the point B. The length of the radius of the circle equals to the length of BC. The surface of the circle is the base of the cone. We have straight line AB is the axis of the cone, is perpendicular to the base of the cone. The height of the cone equals to the length of AB. Example, we have here a right circular cone. The length of its drawer equals 17 centimeter. Means L equals 17 centimeter, and its height equals 15. So H equals 15. Find the length of the radius of its circle. We have here the cone. L is the drawer. R is the radius base. H is the height. Solution. Let the length of the cone drawer equal L and its height H. The length of the radius of the base circle equal R. So from Pythagoras theorem, R power 2 will be L power 2 minus H power 2, and R power 2 equals 17 power 2 minus 15 power 2 equals 64. By taking the square root of the two sides, R here will be 8 centimeters. We have here cone vertex. If we have a paper like that, cone drawer, cone vertex, and the lateral face. Lateral face will be a circle, and dn is its radius. It will make a cone like that. AB and AC equal L, the length of the cone drawer. The circular sector ABC shows the lateral surface of the cone. The length of BC equal 2 by R, which is the circumference of the circle. R is the length of the radius of the cone's base. The height of the cone equals the length of AN. Example, we have this one. We have the opposite figure shows the right cone. Using the given data, find the height pi equal 22/7. Solution here. The length of the cone drawer equal length of MA equal 21. Circumference equals 44. So the length of the radius of the cone base length equals Cn equal R. By folding this figure, we'll get 2 by r equal 44. And as a equation, we will find r easily equal 7 centimeter. And we will find h, which is h power 2 equal L power 2 minus r power 2 by Pythagoras theorem. So h power 2 equals 21 power 2 minus 7 power 2, each equal 14 root 2. So height of the right circular cone equal 14 root 2. The area of the cone equals half times AB times length of BC. So it's equal half L 2 by R equal pi LR. Its literal area. And we will add it to it the total area to find the total area. Pi LR and pi R power 2. An example here, literal area and total area of the cone. If we have L power 2 equal 20 power 2 plus 15 power 2 equal L equal 25, and literal area will be pi LR and equal 25 times 15 pi. Another example, to find the area of this part. This part is a cone and another cone with each other. Solution, the area equal area of first cone, literal area only, and literal area of the second cone, and we will add it then. We'll run to volume of the cone. The last thing, we have a cone here and the volume equal 1/3 pi r power 2h. So example here, if we have a cone, an alloy, and we have its height equal 4.5 and its circle's radius equal 1.5, so the gold mass of this alloy equal 191. Yes, the solution, the volume equal 1/3 pi r power 2h and r equal 1.5, h equal 4.2. The volume will be pi over 3 times 1.5 power 2 times 4.2 equals 9.896 centimeter cubed. Density equal mass over volume, so density equal 191 over this number, approximately equal 19.3 grams سنتيمتر كيوب.
تمام مستر عبد الناصر، بنشكر حضرتك على وجودك معنا النهارده واتاحه الفرصه الجميله. شكرا يا فندم. اعزائنا الطلاب، بنتمنى يا رب ان حلقه النهارده من برنامجكم تبسيط العلوم تكون نالت اعجابكم حتى نلتقي مجددا. شكرا لكم.